Alright guys, it's Unit 7 Day 6. It should be Friday's work. Um, so this is gonna be the lesson after Thursdays obviously. It's gonna go a little bit more in depth, but we're gonna get through it. Okay? So the first thing you gotta know is the expected value sum, right? This right here, the expected value, we know that this is the another word for the mean, the average. Okay? And what does sum mean? Sum means you're adding. Okay? So this little formula right here, all it just means is when you have two different expected values from two different items, two different variables, you're just going to be taking the mean of each one and you're adding them. Okay? So let's break up that formula right here, right? So first we have e of x plus y. Okay? Remember, the e from yesterday is the expected value. Okay? The e is the expected value. Okay? So how you're going to calculate this? Well, this is going to be the mean of your x plus y. Okay? So the mean is another word for average, right? This is your mean. Okay? So this right here is just a simple way of saying the mean of x plus the mean of y. Okay? And you're done. Okay? Is everyone alright with that? I expect you guys to read this so you guys can get more familiarized it with the concept. But this is just the basic thing for this one. Okay? I'm going to save all my time for another problem that requires a lot more effort. Alright, so before we go on to the next section, there was a part of yesterday's lesson where it said the variance of ax is equal to a squared times the variance of x. Okay, guys, and I said in yesterday's lesson that this square does not need to be there. I made a mistake. The square has to be there. If you take out the square, it only works for when you're doubling something. Okay, if you're tripling something, this square matters. Okay, this is only, you don't have to have it only if you're doubling something. Just to make that clear. So if you have a certain variance for a certain independent variable, if you're tripling something, quadrupling something, then you plug in the 4 here squared and then you multiply it by the original variance and then you should get your answer. Okay, so this section right here, what is it saying? The variance of the sum of two independent random variables, right? So what are you going to be doing? You're going to be taking your variance of your x plus y and you're going to be separating it into each one. Okay, so what does that actually mean? Well, let me get the correct angle, right? So the variance of x plus y. Okay, what does that mean? That's going to mean the standard deviation of your x plus y squared. Remember guys, this right here is your standard deviation. Okay, this right here is your variance. That's how both of those are related. Okay, so from here, so how we get standard deviation by itself? Well, if this is being squared, we need to get rid of that squared, right? So the formula for standard deviation of x plus y, okay, remember again, the x and y are two separate items, two separate topics, okay, two separate variables, should I say. So the standard deviation of x plus y is equal to, okay, so what we're gonna do, or here's the formula, let me just give you the formula, is gonna be the square root of your standard deviation of your x squared plus your standard deviation of your y squared. Okay, that is the formula. If you have three separate variables, you have three separate standard deviation squares, right? the standard deviation of x squared plus standard deviation of y squared and plus z squared, right? You get the idea, okay? One thing to note, very important, never, ever, ever subtract, okay? You only add, okay? Never subtract, you only add, okay? So let's break this down a little bit. So here we have an example, right, of X and Y, right? The variance of E plus W, you're going to separate them out. So we have this, right? So what does this mean? Well, the variance of E is equal to 149,600, and variance of W is equal to 149,600. Okay, so the total variance would be this amount right here. Okay, that amount right there. Remember variance? You're just simply adding them, right? Simple, easy, done. Now, this problem, this next part, this next sentence, where it says that Mr. Eeks was insured for twice as much, right? This is from yesterday's lesson, right here, right, where the word twice in it, doubling it. Okay, so right here, the variance of 2x. Well, we know that your x is, we already have it as 149,600. So this 2 is going to be squared following the formula, right? So 2 squared times the variance. So it's going to be 2 squared is 4 times that. So that's going to be the variance, okay? Variance. So if you continue reading, right, to solve for standard deviation, if we have variance, we need to take the square root, right? To solve for standard deviation, we need to take the square root. So that's what they do over here, right? So the standard deviation of the two items, two independent policies, right? So your first one, 299,000, we take the square root, that's going to be the first standard deviation, right? And then for the next one, you take the square root, that's going to be the second standard deviation, okay? So that's what this paragraph is saying. Again, read it so you can understand it more in depth, okay? Now the next part, I'm sorry I'm going kind of fast. Yeah, I just don't want to forget the other problem. So now the variance of difference, okay? Difference, as we all know from before, from elementary, is subtract, okay? Difference means subtract. So hence why we have a subtraction, right? But what do we know about our rule? We never subtract, we only add, okay? So this is gonna be our formula, right? The variance of x minus y is equal to x, the variation of x plus variation of y. This paragraph explains a little bit of why it's adding and not subtracting, okay? Basically, after you read this, basically it's saying, from this example, you have 1,000 or 10,000 minus 0. That's going to be a difference of 10,000. Okay, and then if those two are reversed, 0 minus 10,000, you're also going to be getting negative 10,000. Okay, well, what do you know about these two? Well, there's a spread of $20,000. Okay, and that's what this is saying. Okay, it's taking into account of both numbers being reversed, right? So you have a negative side and a positive side. Okay, so therefore, what you should remember about variance, right? You should always add. Okay, for variance, you always add. Okay, so read these more in depth. Read it slowly. Pause the video if you need to, so you can fully understand it. Okay, so let's go on to the next page. Okay, so I'm gonna let you read that one, but put a little star right here Okay, because that is very important. Okay, all it's saying is what the last paragraph was saying. You should only add, never subtract. Okay, hopefully that was a little bit more clear. But now for the big question, number 35. Okay, I'm gonna try my best to fit it in here, but if not, I have a separate paper just in case. So make sure you have your calculators ready, so we can do that problem. So let's do the first one. So I'm gonna give you guys like 30 seconds to read it. Pause the video if you need to. All right. Let's see. All right. So we have a small bowl with a mean of 2.5 ounces, right? And a standard deviation of 0.3 ounces. Okay. So, and then we have a large bowl with a mean of that and a standard deviation of 0.4. Okay, so let's start labeling variables, right? So our x and our y. So our x variable, let's label that as your large bowl. And the y is our small bowl. Sorry guys, it's kind of hard to write and record. All right, now the next part. We have a mean, right? So our mean is our expected value, right? Mean, expected value are the same thing, right? Mean and expected value are the same thing. So let's label that. The expected value of your x is your mean, which is of the large bowl. Where's your large bowl? Large bowl expected value is 2.5. I should have done the decimal one first so you don't get confused, right? Sorry. And then the expected value of the small bowl is what? The mean of the small bowl is 1.5. And then the standard deviation of the large is 0.4. Standard deviation of your small one was 0.3. Okay, so we labeled everything. We have that taken care of. All right, now let's get into the real problems. So the first one, how much more, right? What does how much more? That right there is a difference. If we can remember back in the younger days, right? How much more, right? It means subtraction. Okay, and then expected is your expected. So what are we doing? So for A, we are finding the expected value of your x, which is the larger bowl, right? Expected for the larger bowl, so x minus y. So expected value, you take them each separate. Expected of x minus expected of y from yesterday's lesson, which is 2.5 minus 1.5, which is 1 ounce. Perfect. Now B. Find the standard deviation of the difference, right? Difference again is subtract. Okay. So now we're in B. So now we're finding the. So remember, standard deviation from our formula is the square root of the variance squared. Okay. So the variance of x minus y is equal to. Now we're taking the variance of the small. So how do you write this? Standard deviation of your x squared plus standard deviation of your y squared. Okay, so that's going to give you 0.4 squared plus, remember, variation is always addition, never subtraction. 0.3 squared, which should give you 0.25. Oh, sorry. 0.25. Okay, remember, um, standard deviation squared, 0.4 squared plus 0.3 squared, and then we got 0.25, right? And then now standard deviation is equal to the square root of the variance of your x minus y, which is the value that we just got, but you take the square root. So it's going to be square root of 0.25, which we all have a calculator. So the standard deviation, SD, is equal to 0.5 ounces. Okay, boom, done. Keep in mind, guys, we squared it and then we take the square root. Square separately and then add and then take the square root. That's going to come up on another problem. Okay. C. What is the difference? If the difference is followed by the normal curve, okay, normal curve. That should ring a bell. Normal curve, probability. Oh, there you go, probability. So here, the normal curve, you remember when we did the z-scores? This is going to be one of those problems. The z-score. Oh man, kind of wrote it on the paper. All right, so this is going to be a z-score problem. Okay, the normal curve. C. So probability that the small bowl contains more than the large one. The small contains more than the large. Okay, so we have the probability. Which one's the small again? Your y. So probability of the small minus your large, right? The probability has to be greater than 0. Okay, because we're trying to check the small bowl is larger than the large bowl. Okay, so what do you do first? All right, so now we need to find the expected value. Okay, so if we the expected value of y minus your x, remember the small bowl is larger than your large bowl, is going to be 1.5 minus 2.5. Okay, that gives you -1. This -1 is the mean, your x bar. Okay, good. Now we need to find the z-score. So we can remember the z-score is equal to your x minus your x bar over your standard deviation. You guys remember that from like 2-3 units ago? All right. So what is our z-score? Well, it's going to be your x variable is going to be 0 minus your mean, the new mean that we calculated. Okay, over what is our standard deviation that we got from part B? Standard deviation 0.5. Okay, so you should have gotten 1, positive 1 over 0.5, which is 2. Remember, guys, this right here is your z-score. Okay, that's your z-score. So now we have probability of the z-score being what? Contains more cereal. So greater than 2. Remember, more, not less, more. Okay, so if we think about the normal curve, right? Remember, right smack in the middle is your mean, and then 1 standard deviation, 2 standard deviation. Okay, and what we're looking for? 2 standard deviation of your z being on the greater side. Okay, so there's a way, if you guys can remember, for us to do in the calculator. Okay, so this is gonna be just to remind you, the normal CDF. Okay, that's gonna be the normal CDF. So I want everyone right now to get a calculator to follow along. So if you have stuff, exit out. So we can do it right here. Hopefully everyone can see. So menu. I'm gonna go to, which one was it? Probability. Not random distributions. Probability distribution. So again, exit. Probability distributions. And it's going to be the normal CDF. Normal CDF. Okay? These two are almost the same, but this one, the PDF is when it's exact, so the z-score is exactly 2. This one is when you have a inequality, so greater than or less than. Okay? So the lower bound, so you see how in our graph we want it to be greater than 2, right? So 2 is our lower bound. So you're going to take that away. You're going to type in 2. And then our upper bound, that's going to be infinity. Your guys' calculators don't have infinity, so we need to put a couple 9s. Enter. Boom. That is our answer. Okay? That is our answer. So, just so we can get full credit on the test, it will be 2, or we can put normal CDF, 2 to infinity, 0, and 1, right? This is the lower bound. This right here is the upper bound. This right here is the mean, and that right there is the standard deviation. Okay, and our answer that we just got was 0.0227. Okay, whether you round it or not, it's totally up to you. Perfect. So that was C. D. Oh man, we're barely halfway. All right, let's see D. So what are the mean and standard deviation of the total amount of cereal in the 2 bowls? Okay, so the mean and the standard deviation, right? So we're adding. So the expected mean of your x plus y. Okay, so of the 2 bowls together, combined together, that is the sum. Oh wait, total of 2. That's a sum. So it's going to be the expected value of your x plus expected value of your y, which is 2.5 plus 1.5, which is 4 ounces. Okay? And then the standard deviation of your x plus y should be 0.5 ounces. Right? How do we get that one? This is from part B, right? Standard deviation, or the standard deviation right here, 0.5, right? Because here we're still adding. So it's going to be all the same work as part B. So same as part B. Okay. Done. That was easy. E. Okay, 2 more, guys. 2 more. So E. If the total follows the normal model, okay. So this is probably going to be a z-score, because anytime it has the normal model, it's more likely going to be a z-score, right? Sorry, normal z-score. Okay. There's a probability that poured out more than 4.5 ounces of cereal in the 2 bowls together. Okay. So we're looking for probability of your x plus y, so together combined will be more than will be more than 4.5. So x plus y will be more than 4.5, and we're looking for the probability. Sorry guys, it shouldn't be a close parentheses right here. Okay, good. So now we have 4.5 minus 4 over the standard deviation of 5, which is equal to 1. Okay? So 4.5 we got from the problem. 4.5. This is from the problem. More than 4.5. Okay? 4.5. We got the 4 from the one before, the mean. So right here is your mean. That's your x bar. Okay? Over standard deviation, we got from the problem from part B, right? Same thing. So this is right here, that's your z-score. Z-score. So now we're looking for the probability of your z being more than 1 from what we got. Okay, so same thing that we just did before. the normal CDF. So we're looking for more than one. Is going to be 1, 2, basically 9999, 0 to 1, right? What is that probability? So same thing, right? So menu, probability, distributions, normal. So the lower bound will be 1. The upper bound, since we can't put infinity, it won't work. We gotta type in a couple nines. And there you go. That is our answer. Okay? The 99999, that is another word, another way to put infinity. Okay? So the probability is gonna be 0.1586. Done. That is our probability. Okay, over here the difference would have been this part right here. This little piece will be shaded because that's one standard deviation, that's 2. Right here was greater than 2, so only that was shaded. For this problem, it's greater than 1, so from 1 on to infinity, we will shade that. Okay, and our last problem, F. Okay, so let's see. The amount of cereal the manager puts in a box is a random variable with the mean of that and a standard deviation of 0.2 ounces, right? So since we already have X and Y labeled, let's label this one as Z, right? Which is the cereal box. From manufacturer. Okay. So F. So basically find the expected value and what's left, the expected value, what's left, and the standard deviation. So expected value that's left. So we have your Z, because that's how much the cereal box contains, right? And we're subtracting the large bowl and the smaller bowl, right? So Z minus X minus Y. So again, Z is this whole cereal box. We're taking off the large bowl and taking off the small bowl. Okay, so basically it's gonna be the mean of Z minus the expected value of your X, which is the large bowl, minus the expected value of the small bowl. The large bowl, small bowl. So this right here was the mean, or 16.3, right? Minus 2.5 minus, what's the last one? We can look at it over here. The mean of Y, 1.5. Right? We solve all that. That should be 12.3 ounces. And finally, our last problem, our standard deviation. Okay? So remember, guys, standard deviation we did over here is to be the square root of the variability, right? So the variance, I mean. So remember, how do we calculate variance? It's you take each standard deviation and you square it separately. Standard deviation of Y squared, okay? So here, standard deviation is gonna of your Z minus your X minus your Y, okay? Remember, guys, for standard deviation, never subtract, you always add. So it's gonna be the square root of, so the standard deviation was of the Z was 0.2, so 0.2 squared plus, what's the next one? Standard deviation of X. So standard deviation of your X was 0.4 squared plus standard deviation of Y is 0.3 squared. Type that onto your calculator and you should get 0.5385 ounces. And we're done. Guys, this was the longest problem. We did a couple of older things about the Z-score, okay? But pause the video whenever you're having trouble and do the rest of this packet, okay? Again, guys, this is Friday's work. I will be there Monday, and I miss you all already, okay? See you soon, guys. Bye, guys.